So I showed you an example of a bow truss that we created in Grasshopper. We went through the recipe, so try to understand step by step what we're going to try to accomplish. In this video, we're going to build it from scratch. I can hardly wait. So let's get started. All right, so just as I mentioned before, I have my starting ingredient here in Rhino, or I could bring this in from AutoCAD or anything really. A line, something that, for instance, I could demonstrate, the length of the span that this truss has to withstand. And so with that, let's open up Grasshopper. I'm going to type in Grasshopper as a command. There's our truss recipe. I'm going to go ahead and close that. And I'm going to build this thing from scratch. So I'm going to say File New. Oh yeah, there it is. All right. Not sure why I have to do that, but okay, there we go. All right, and so first of all, I have a piece of geometry in the Rhino native modeling space, and I want to bring that into Grasshopper so I can reference it, refer to it, and build lots of parametric things off of it. Okay, and so if you remember, we'll go to the Params tab. The Params, short for parameters, right? Params tab. Geometry. Here's a bunch of placeholder widgets for different types of geometry I can bring in from Rhino. So I can place curve. Line is a curve, right? And I can right-click on this widget. I can say set one curve. Grasshopper will disappear. It's really prompted me to select a curve in Rhino, which I'll do. I'm going to go ahead and give myself a little more space in this command line. I'm not sure what's going on with my view, but all right. So select that curve, click, and Grasshopper reappears. That widget is highlighted green. Whenever I highlight a widget in Grasshopper in the graph, it highlights whatever geometry is being created in that widget here in Rhino, green as well, right? So there it is. I can see it's there. And I can now build off of it. We're referring to this curve right here in this widget. So I can plug this in whenever I need a curve as an ingredient. Wham. All right. So a couple of things, right? Just thinking a couple steps ahead. We need to place a point along this curve and build up from it, right? A sort of vertical pull to sort of make an inverted T. And then we'll find endpoints and start points and things like that so we can actually create a bow, right? If you can follow my cursor along there. And so first we'll place that point. If I have a curve and I want to sample and actually populate it with a point, I can go to Analysis, Evaluate Curve, right? I went to the Curves tab, of course. Anytime I want to make curve or do something with a curve, I go to the Curves tab. Yeah. Same with surfaces, and points, of course, are in the Vector tab, as we mentioned before. So there it is. Evaluate curve with the T parameter. And of course, I can plug in the curve. And the next ingredient is the T parameter. That's a numerical address along that curve, right? And so I'm going to use a number slider so we can adjust that really easy. By default, when I pull out a number slider, the minimum is set to 0 and the max is set to 1. That actually works out really well. If you'll remember, what we try to do is actually use 0 for the beginning of the curve and 1 for the end of the curve. And so by default, curves aren't usually normalized between 0 to 1. So if you can see, I just plugged in this T parameter. Actually, our curve is a lot longer than just 1 unit, right? And so when I go all the way to 1, it's only going like partially along the curve. That means I need to right-click here where I'm plugging in the curve to evaluate it and tell the widget to reparameterize the curve. And what that does, again, this is a rehash of something before, but we'll just continually repeat it because this is going to be an issue you'll run into constantly. We'll reparameterize it. We'll tell Grasshopper to take whatever that minimum and maximum value of that curve is and then normalize it so that the minimum is 0 and the maximum is 1. So reparameterize it. And now suddenly I can go from 0 to 1 and get from one end to the other. Halfway is 0.5, 3/4 of the way is 0.75, etc., etc. All right, so there we go. We have our point. And that's not the only point we need, but from here, let's build our vertical line. Again, a line is a curve, so we're going to go back to the curve tools. There we go, curve tab. And there's several different ways to build a line, right? In fact, there's more ways than you ever thought, probably. Some common ways, right? A start and an end point. That seems like a pretty easy way to define a line. In this case, we only have one point, and we want to build a vertical line. So, sometimes you're just looking at like, okay, what are the different methods to build a line, and then what ingredients do I have in order to accomplish that? And that helps you pick the method you use to build this line. In this case, we have line by start point, direction, and length, which is exactly what I want. We're going to use this new point that we created to create our new line. The direction, by default, is already set to the world Z. It just happens to be a nice coincidence. And the length, that's something that's a variable. That's a parameter that I want to be able to change over time. So I'm going to go ahead and plug in a number slider. In this case, maybe I'll change the minimum and maximum value. So the maximum value, maybe I'll change it to something larger. Give me a little more flexibility here to make this thing tall. And maybe that's a little extreme. It's kind of, usually trusses are longer than they are deep. And that's why they're efficient and spanning long distances. But anyway, here we go. Okay. In fact, you know what we could actually do? Ooh, later on. Oh, we could sample the length of this curve, right? The length of the span, and then make the depth a function of whatever that length is. Oh, that would be so awesome. Maybe we'll do that at the end. Sounds like a great idea. I'm so smart. Anyway, so now we have our scaffolding. We have the sort of horizontal span. We have the vertical depth defined. Let's find the start and end points. So again, we're sampling properties of curves. So I'll go to the Curve tab, Analysis, and here we go. Endpoints. Extract the endpoints of a curve. I'm going to go ahead and select that. I can just copy and paste on my keyboard. Look at that. Control-C, Control-V. Because I'm going to do it for this curve, this original curve, right? So there's my start and end points. They're highlighted in green. And then I can also do it for this new vertical line. There's my start points and end points there, highlighted in green. Oh yeah, there we go. And so now let's draw our spline. So we can, we're basically drawing the shape of our top chord. So I'm going to use an interpolated curve. And I recommend you use this exact same widget for now. Later on in person, maybe we can talk a little more about the different types of curves and how how they react to the vertices that we plug in for them. But for right now, I'm just going to tell you, interpolated curve is going to be your best bet here. Okay, and so watch what happens when I try to plug in multiple values. It just replaces the first one, right? We need more than one vertice, more than one vertex, more than one point, right? In order to create a curve, right? And so as I try to plug in more than one point, it just replaces whatever I've done before. Now, how do we fix this? I'll go ahead and disconnect this stuff. You can't see this at home, but I'm holding down the Shift key. And now I can plug in multiple things. Okay, and so I want to do this in a particular order. If you think about this, I want to do the start to this end to this end. And so I'm going to use the start point and then the end point of this vertical line and then the end point of our original line. And voila. So it's really important that you do this in the right order of how you want to connect the dots. Grasshopper, I mean, you would want that control anyway. So you want to make sure that that you do it in the right order here. So if you have it looks like a straight line, then you've probably connected the start to the end instead of the start to the end to the end, right? So it's about making sure you're connecting up the right points at that point. All right, at that point, pun intended. Oy, oy, oy. All right, so here we go. Now we have our bottom chord, right, and our top chord. Right? And so from here, we're going to divide these to generate a set of points or populate these with points that we can start to, again, we can start to connect these up to create the sort of cross webbing and cross bracing that you typically see in trusses, right? So this is something I mentioned when I was looking at the recipe. I turned the preview for some of this geometry on and off. And so we built this thing up step by step by turning the previews on as we went from left to right through the recipe. In this case, I know that it's going to generate a point here, and then it's going to build a line from that point, and then it's going to find these points and then draw this curve. I don't necessarily want to see all of that construction geometry now. So I'm going to turn some of these things off. I'm just right-clicking on the widget, right? If you right-click on the middle and the label for the widget, right, you get this preview that you can toggle on or off. And it's still generating all this geometry in real time. But what I'm doing is I'm just saying I don't want to actually see it in Rhino. Okay, so that can sort of resolve some of the visual clutter as we move ahead, because we're going to generate more points. And so what I don't want to do is get confused by seeing this point or these points. And I want to be in the moment and sort of understand what I'm doing step by step. All right, so once again, we're already in the Curve tab here for our tools, and so we've already evaluated curve at a t parameter. And now we're going to divide curves. So I'm going to use divide curve. And I know I'm gonna do this a couple of times, so I'm gonna, again, copy and paste this widget. So I'm gonna use this curve and I'm gonna divide it, right? By default, it's already divided 10 times. That's just the default number that it puts in the widget until we plug something different in. And I will, I'm gonna actually use a number slider. So let me go ahead to params and number slider. And like I said, sometimes I go fast. I mean, that's the nice thing about these videos is that you can pause them and then even, go back 10 seconds and like, what the heck did he do again? So you can always refer back to this, right? At this point, I'm building this step by step, so I expect you to probably use this to try to build this step by step back at your laptop as well. So 0.25, let's see. So it doesn't make a lot of sense to try to divide this line 0.25 times, right? You either divide it once or 6 times or 18 times or whatever. So I'm going to double click on this number slider to bring up the properties box as we've done in the past. I'm going to constrain it to integers. I'm going to say, well, we're not going to really divide anything by 0. That's just not a good thing to do in math. And for the maximum, I'm just going to give something ridiculous like 30. That way we have a lot of flexibility in the range here. We can populate this with all kinds of points if we want to, or we can be a little more conservative. All right, and so interestingly, I'm going to use the same number slider for this one as well. Because of the nature of connecting things with these trusses, the bottom to the top, if I adjust the top, I also want to adjust the number of points along the bottom at the same time. So I'll just use the same slider for the number of divisions for the top and the bottom. And that way, when I don't break something, as I'm sometimes prone to do, I'm kind of klutzy. All right, and so here we have a list of points coming out. So we're dividing this 14 times, we get 15 points out. That makes sense, right? Each of these segments are one of those divisions. So we have 14 of these line segments, and so we have points at either end, and so that adds one additional point to, however many divisions we have, we'll always get that number of divisions plus 1 point out. So 15 points because we're dividing this thing 14 times. All right, so at this point, I hope you're ready for this, but we have a list of start points and we have a list of endpoints. Let's go to the curve tab and let's go to primitives. Now we can create a line by start and endpoint. All right, so here's where I plug in the start points. Here's where I plug in the endpoints. If I do one start point and one endpoint, I get one line out. But if I plug in a list for each of them, then I get a list of lines out. So here's 15 lines because I plugged in 15 start points and 15 endpoints. Okay, and those are our sort of one-to-one vertical, the vertical webbing for this truss. And now here's the trick, and this is one of the reasons in one of the previous videos, I talked about shift list in particular. Remember, we can take a list of points, and we can take the first point and shift it to the back, and everything moves up. And that's what we're going to do here. So we're going to shift the list of points. So then instead of matching up this one to this one and this one to this one, right, we're going to match the first one to the second one, and the second one to the third one, and the third one to the fourth one, and the fourth one to the fifth one. Okay. So what I'm going to do is I'm going to shift this list of points. So I'm going to go to sets. Remember, this is where I can reorganize lists of objects and numbers, right? So list and shift list is one of my options. Okay. All right. By default, the shift offset is already to 1, so I'll take the first item and shift it to the back. So I'm going to plug this in. I'm going to shift this list of points. Okay, and so I have the shifted list of points here, right? That for the top, and I have the unshifted list of points along the bottom. And I'm going to create a line between those using this as the start and these are the ends. Okay, so I'm going to go back to curve, line, and there we go. And sound effects, of course, are optional at this point. I don't know why I do them. It's a bad habit. All right. Now, what you'll notice is that by the time we get to the end, right, it'll take our last point and connect it up with the first point from the other one, right? And so your truss might look a little goofy. So what I'm going to do is I'm going to tell it actually to not wrap. In other words, don't take that first value and put it at the back. Just get rid of it. And that's going to save us a little bit of trouble there. Okay, there we are. Oh, yeah, all right. And we're going to do the exact same thing, but instead of shifting this list of points, we're going to shift this list of points. So we're going to make a set of lines from this original set of points and then the shifted list of points here along the bottom. So thank you, UNLV today. I'm sure you guys get those as well. It's so annoying. All right, shift list. Here we go. So we'll shift this list of points and we'll create another set of lines. And we'll connect up these points with this shifted list of points. Again, I'm going to go back to wrap, and I'm going to turn the Boolean, say don't wrap that, and there we are. All right, look at that. Okay, and so at this point, we have a fairly variable truss. Oh yeah, look at that. We can change the shape of it, and of course the height or depth of it, right? And then of course the spacing and density of this, so the number of componentry on the inside, and oh yeah, look at that. Incredible. So there's one additional thing that I talked about. I think that'd be pretty interesting to try. But right now we're just using a number slider, and I can change that to anything in order to create this sort of height or depth of the truss, right? And what I mentioned before is that maybe we take a look at this line that we drew, the span, and measure it, and then, make the depth of the truss some sort of dependent or associated with the span, right? Which makes sense. I mean, that's how structural relationships work, right? With beams and trusses and anything that has to span from a column or between columns or between load-bearing walls, right? So let's try that out. What we're going to do is at this point, you have a truss, right? And so I'm just going to modify this. You should probably save right now. And then you can also save as and maybe change the name to something like Truss 02. And that way you can always refer back to your simple truss and then a slightly more complex version, right? And then a slightly more smart version of it, right? So you can always sort of version these things out so you don't actually lose information. Or if you actually mess up in this next step, then you can always revert back to the last known working version, right, that you have here. Okay, that was a long thing to say, just to remind you to save. Always save. Just get in the habit of hitting Control S all the time. So anyway, what I'm going to do is I'm going to look back at this original curve that we drew in Rhino, right? It's referenced here as our starting ingredients, and I'm going to go to curve, and I'm going to go to analysis, and I'm going to say, find the widget where I can measure curve length. All right, and there it is. So I plug in a curve, and it's going to spit out a number, and that's the length. In this case, the length is 8.825334 units, right? I don't know what the units are. Feet seem like that's not a very large span. Maybe those are meters. I don't know. Whatever. And what's interesting is that what we'll do once we do this is I'll start to draw more curves or more lines with different lengths, and then we'll basically change this little initial ingredient, right? And then we'll watch everything sort of change with it. So anyway, here's the length. And so maybe we do a little bit of arithmetic. Maybe we say, let's see, where is it? Oh yeah, math. That would help, right? So let's do some division. So we'll take this and we'll divide it by 12. Why not? Right? So whenever the input wants a number, I can right click and it's for a data item. If I don't want to actually change, I can just change this ever. I just want to enter in 12. I know what that's going to be. And let's say the structural formula is never going to change. So L over 12, the length of the truss, the length of the span divided by 12, we'll use that as the height. I don't know what a good number would actually be. Maybe we can ask one of our structural engineer friends later on. I have a good colleague that I can ask. But anyway, at this point, in fact, she teaches one of your studios, I think. So let's plug that in for the length, right? And so now, right, I can't just adjust the depth of this truss all willy-nilly, but it's actually going to be informed by this length of the span that this truss has to cover. So now, of course, I can draw any line here in Rhino. Okay, and I can make a truss from any line, right? That's all it wants is a simple ingredient like a line, right? So you can see, right, that length is smaller, and so of course our depth is smaller, right? Again, the starting ingredient right here, this widget, I can say set one curve and pick a different curve, and then suddenly I have a truss along that line, right? Or along this line. Wowie, there we are. All right, great. So, at any rate, there we have it. What I'm going to do is I'm going to end this video, and then in the next video, I'm going to give you instructions for what I want you to submit for over this week. Okay, so sit tight. I'm going to end this video, save it, name it, probably start uploading it to YouTube. It takes forever. And while that's happening, I'm going to record the next video, which will talk about the assignment. Okay, see you soon.